In this problem, we're going to take a look at a basic type of projectile motion problem. And here we have a marble that was set onto a table, and it just happens to roll off the table onto the floor. And the marble lands 33 centimeters away. So how fast was the marble rolling whenever it fell on the floor? So here's a picture of what's going on. Here's our tabletop. Here's the marble, which has an initial velocity in the x dimension. The marble falls to the floor and it lands 33 centimeters away. So dx, or the range, is equal to 33 centimeters. So the first step to solving this problem is going to be to write out our information for the x dimension and y dimension. And in the x dimension, dx is equal to 33 centimeters. Vx is what we're looking for, and t is an unknown quantity. In the y dimension, we have dy is equal to minus 1.3 meters, and the reason it's minus is because it is below where it started. Displacement is a vector, and so this is a negative displacement. We have v initial y is equal to 0. V final y is an unknown quantity. Ay is equal to g. And t is again an unknown quantity. So we'll start by writing our equation for x, which is dx equals vx times t. And dx is a known quantity. Vx is unknown, that's what we're looking for. And then we have t, which is an unknown quantity. Now there's nothing more we can do in the x dimension, so that's going to force us to look at the y dimension. Now in the y dimension, we need to write an equation. And if you look at our equation sheet, we've got several options. So which option is going to be our best option? Well, we know the displacement, the initial velocity is 0, and we know the acceleration, but we don't know time. So this equation can be solved for time, and we could substitute that in the time in our other equation, or vice versa. So this looks like a promising equation. The problem with the acceleration independent equation of motion is that we don't know v final. Now it's something we could calculate, but that just means it's extra work. So that's not our number one pick because we want to do as little work as possible. And then finally, we have the time-independent equation of motion, and that also could work, but again, we're introducing v final into our equation, and that's something that we don't know. So our number one pick here is going to be the position function. So we're going to write d is equal to v initial t plus 1/2 at squared. And remember, this is all for the y dimension. All right, now v initial was 0 in the y dimension, which is going to leave us with dy is equal to 1/2 g t squared. Notice I did not put a negative sign in here. I will not do that to the very end. G is going to be equal to a minus 9.8 in this problem because downward is the negative direction. So now we have a choice. If we go through our checklist in the y dimension, what we see is dy is a known quantity, g is a known quantity, but t, that's not a known quantity. So what do? Well, we could either solve this equation for t and substitute it in to the y equation, or we can solve the y equation for t and substitute it into the x equation. My advice would be to solve the x equation for t and substitute that into the y equation, because then we won't have to deal with a square root. So let's do that. So we're going to get dx over vx is equal to t, and now we'll substitute that into this equation. dy is equal to 1/2 g times the quantity dx over vx, quantity squared. Now we should be able to calculate what the speed of the ball was. So solving this for vx ultimately, dy is equal to, let's see here, 2 dy is equal over g is equal to dx squared over vx squared. So solving this for vx squared, we're going to get vx squared is equal to dx squared times g divided by 2 dy. And so finally vx is equal to the square root of dx squared times g over 2 dy. Now let's substitute our values in. Dx was equal to 0.33, and that quantity is squared, times a minus 9.8 divided by 2 times a minus 1.3. So you see, once again, these minus signs on these individual vectors were necessary because they have to cancel out under the square root. So let's go ahead and compute. We're going to have the square root of 0.33 squared times 9.8 divided by the quantity of 2 times 1.3. And the initial velocity was 0.64 meters per second.